Ready? Welcome to 10.3. We are going to talk about chords today. So take a few moments and review a little bit of what you know about triangles, arc measures, angle measures, and see if you can work on this bell work. Go ahead and pause and take a few moments. Okay, so if you are looking at this, they gave you two different triangles within this circle. Notice that A is the center point and that intersection is not at A. These are not central angles. However, they are vertical angles, so we can still use that to our effect, and then this angle would be vertical with the 75.7. So if we were to find the measure of angle BFC, hopefully you started thinking that this 75.7 and angle BFC, which is this guy right here, those make a linear pair. So the measure of angle BFC would be 180 minus the 75.7. So the measure of angle BFC should have given you whatever that supplemental angle is, which is 104.3 degrees. Now, once you found that, it is vertical. So then the measure of angle BFD, the measure of angle DFE would also be 104.3. So that is this angle right there. Now the next one that they asked you for is the measure of angle BED, which is this guy. So if we found the measure of angle BED, we would simply take 180 degrees because we now know that the angles of a triangle add up to 180. Subtract the 25.1 at angle D and subtract the 104.3 that we got for the vertical angle, and then we would be left with just angle BED, which is 50.6 degrees. Hopefully you're able to figure that out. And then last but not least, a little bit of review. Arc DB is this guy. Well, arc DB is the intercepted arc of this angle here. So we know that this angle was 50.6 and it's touching the circle, so it's an inscribed angle. So that means the measure of arc DB would be double that inscribed angle. So 2 times the 50.6 degrees. So then the measure of arc DB would be 101.2. Hopefully you got that there and you're all warmed up, or at least it's a refresher. We're going to jump into chords today, a few different properties of them, and a couple ways to actually use them to solve for different pieces and parts of the circle. We're going to talk about arc measures, angle measures, that kind of stuff. For this week, actually, you're going to take the homework from this section today and then the homework from the next section that you guys will have next class. That's going to act as like a review and some practice problems for your next quiz. And then we are moving on to our last topic of the year, actually, which will be volume. So pay close attention to the notes today in the next class, and then obviously your homework. So a quick review, a chord is a line segment that has endpoints that are on the circumference, meaning as long as the endpoints touch the circle and they're on the circumference, this is now a chord. And then recall a chord that goes through the center, this would be called the diameter. Still a chord, but a chord does not have to go through the center, the diameter has to. If we look here, there's a couple of different ways we can talk about chords, a couple of different properties. Our first thing that we're going to talk about is congruent chords. So there's two specific ways that congruent chords can help you. This first topic here, or this first big idea, if you will, says that two minor arcs are congruent if and only if, that's what IFF means, their corresponding chords are congruent. So they're saying that if this chord equals this chord, then that means this arc, LM, is equal to this arc, XY, and vice versa. If we knew the arcs were equal, then we could say that the chords were equal. Okay, so let's look down here at this example. It says right here that these two arcs are equal. I'm sorry, these two angles are equal. These are located at the center, which means that they're central angles, and the arcs that they open up to will have the same measure. Well, if this angle equals this angle, and then this arc equals this arc, that means that this chord equals this chord. So we can go ahead and say that AE is congruent to BD, or the distance between A and E equals the distance between B and D, and then we can simply say 2x minus 5 equals x. Algebra happens here. We could add our 5 over, subtract our x over, and then we get x equals 5. So just a quick little way to use arcs and chords here. So congruent chords mean that their intercepted arcs are congruent, and vice versa. If the arcs are congruent, the chords are congruent. Let's look at the second big idea with congruent chords. So our second big idea says that if our chords are congruent if and only if they are the same distance away from the center. So if this was our center point right here, and this distance were equal to each other or congruent, that would mean that this chord has to be congruent to this chord. So if we look down here, we're determining if JK is equal to ML. So we're trying to determine if JK equals ML. In order for these to be congruent, we would need these measures to be congruent, so the distance from the center. So they said if x equals 7, determine if this is true. So we're going to go ahead and substitute 7. We're going to do 2 times 7 plus 9, and we're going to see if in fact it is equal to 4 times 7 minus 5. Well, 2 times 7 is 14, so 14 plus 9, does that equal 4 times 7, which is 28, minus 5? Well, 14 plus 9 gives us 23. 28 minus 5 gives us 23. Those are equal. That's a true statement. So we would say yes, and we would say that JK equals ML, or chord JK is congruent to chord ML. So because these two distances here were equal, that means that this chord is equal to this chord. All right, so pretty simple here. Let's keep it moving. Another way to use chords to determine different lengths within segments or different parts of your circle is to look at perpendicular chords. So if we look here, if a diameter or a radius, remember, that has to start from the center or go through the center. So this is not a diameter or a radius because it does not go through the center. But here's your center point. This would be a radius. This would be a radius. This line, if we drew this, would be a diameter. Know the difference there and train your eye to look for that. So let's go ahead, and if we look at this particular circle, all right, it says that if a diameter or radius is perpendicular to a chord, meaning 90-degree angle, here and here, perpendicular, then it bisects the chord and the arc. So this radius is perpendicular to this chord. That means that the chord gets bisected, meaning those two pieces are cut in half, and this arc is also bisected. So from here to here would be the same distance or the same measure as from there to there. Similarly over here, all right, if these are congruent, then that means that this arc and this arc are also congruent. So basically the perpendicular bisector of a chord must be the diameter or the radius. So this question says, find the length of the diameter. Well, this is not the diameter, but this is a chord. And because it's perpendicular to a piece that starts from the center, this 9 inches is a piece of the radius. So just understand that if it comes from the center, it is a piece of the radius or diameter. I'm probably going to run out of room over here. Okay, so this 9 is actually a piece of the radius or the diameter. And we know that it's perpendicular to this chord, so this must be cut in half. So they asked us to actually find the length of the diameter. Well, in order to find the length of the diameter, it might help us to know the radius. We don't have a radius or a diameter fully drawn on this diagram, but we can draw one. We know a radius can go from the center point to the edge of the circle. So right now I just made a triangle, and specifically I just made this triangle. Don't be afraid to add lines within your circle to help you out. We know this is 9. 80 was this whole chord, so we know half of it is 40, and now we can use Pythagorean theorem. R is our radius, and that's also the hypotenuse, so we could say 9 squared plus 40 squared equals R squared. Algebra happens here. Square of 9 is 81, and then 40 squared is 1600. So this would be 1681 equals R squared. So then R equals the square root of 1681, which is 41. So this would be the length of the radius. So then our final answer would be the distance or the length of our diameter, which would be 2 times 41, which would be 82 inches. So you're going to get some questions where maybe you have to draw maybe a radius or a diameter to help you out, but using these properties you can find different lengths of the circle. We could then proceed to find the area or the circumference or something like that. Why don't you go ahead and pause and try this one. A little bit more involved, but just try to bisect and dissect that circle and see what you can come up with for the value of x. Just so you understand, the value of x is this segment right here. Go ahead and pause and see what you can do. Okay, as you're looking at this, hopefully you might be able to start thinking to yourself, well, I have a center point, so I know this is a radius, this is a radius, this is a radius, this is a radius. Okay, so that's a start. I do know that I see a perpendicular intersection here, which means that this green chord actually gets cut in half. And that would mean this piece is equal to this piece. So this is also 10.8. Okay. Oh, now I see that I actually have a triangle here. And it's a right triangle. I know I can use Pythagorean theorem with right triangles. So the radius in this case is across from the 90-degree angle. So this would be the hypotenuse. So I could say that 10.8 squared plus x squared equals 12.5 squared. Hopefully you got to this point. 10.8 squared is 116.64. Notice I'm not rounding. Then we have our x squared here. 12.5 squared gives you 156.25. To get x squared by itself, we're going to subtract this 116.64. So we'll be left with x squared equals 39.61. And then x would be the square root of that, which you should get 6.3. So that means x is 6.3. Now let me give you a little hint here. This will be a problem that you might have later on a test or a quiz, but the problem might actually ask you to find this guy. So if we were to try to find this guy, well, we know all of our blue segments in there were the radius. We know our radius is all equal to 12.5, and if we know that x is equal to 6.3, let's just go ahead and call this mystery piece y. We know that x plus y should equal the radius of 12.5. So then y would be 12.5 minus our x value of 6.3, which would be 6.2. I know the question didn't ask us for that, but that's just a little bit of help and a little bit of information that you can use to help you with your homework later. All right, moving on. Let's talk about intersecting chords. So there's two big ideas with intersecting chords. This is the first. If you have two chords that intersect in a circle, the intersecting vertical angles, so the angles that are at that point of intersection, are actually half the sum of the intercepted arcs. That's kind of a lot to digest, but let's look here. So we have intercepted arc y, intercepted arc x. Half the sum, so that means if I took x plus y and then cut it in half, I should get some sort of angle. And the angles I'm talking about are these two right here. So this angle and this angle, these are both vertical to each other. and they're congruent. So that angle at the point of intersection should be equal to the average of the arcs, which is the sum of the arcs divided by 2. So let's go ahead and apply this. It says find the value of x and each identified angle or arc measure. So if I look here, this 3x is this angle. I know it's congruent to this because they're vertical. This 118 is this arc, and then 2x minus 18 is this arc. These are the intercepted arcs, this guy and this guy. So the rule says if I add the two arcs up, so 118 plus 2x minus 18, and then I cut that sum in half, I should get that inside angle. Notice this is not a central angle. It doesn't go through the center, but it's just an intersecting point or an intersecting angle. So this would be equal to 3x. Now, a lot of us kind of freak out here, but let's go ahead and just process this. Let's get rid of that divided by 2 by multiplication. So if we multiply by 2 on both sides, the 2's will cancel over here. We'll have 118 plus 2x minus 18, or the numerator, equals 2 times 3x, which is 6x. Combining like terms, we're going to subtract this 18 from the 118. We're going to get 100 plus 2x equals 6x. Subtract our 2x over. We get 100 equals 4x. And then we get x equals 25. The question said find the value of x, which we did, and identify the angle or arc measure. Well, we knew this was 118, so we know that this angle right here must be 75, because that would be 3 times 25. So we know that's 75 degrees. This angle right here would also be 75 degrees. And then this arc here would be 2 times 25 minus 18. Well, 2 times 25 is 50, minus 18 gives us 32 degrees. Little food for thought here to help you later is, what would this angle be? Well, remember, this 75 degrees here and then this mystery angle should make a linear pair. So this angle would be the difference of 180 and 75, which would be 105. And then 105 would also go there too. Just something to help you out later. You might have a quiz question like that. Okay, moving forward, why don't you guys go ahead and pause and try this one. So use the fact that this arc here and this arc here are the intercepted arcs of this angle and this angle, which are congruent. Go ahead and pause and try. Hopefully you were able to set up your problem. Remember the sum of the arcs. So 3x plus 3, that's the first arc, plus this 10x minus 14, and then all divided by 2 should equal that inside angle. You should have started by multiplying by 2 on both sides. I'm going to go ahead and combine my terms here. So 3x and 10x should give me 13x, and then 3 and negative 14 should give me negative 11. I multiplied by 2 on both sides, so this should equal 106. So then if I add my 11, I'm going to get 13x equals 117, and then if I divide that by the 3, then if I divide the 117 by the 13, I should get my answer of x equals 9. This one said find the value of x and the measure of arc BD. So arc BD would be this guy, which would just be 10 times 9 minus 14. So the measure of this arc should be 76 degrees. And then this would be your answer. All right, last big idea is intersecting chords. So if we're not finding angle measures with intersecting chords, we can actually find lengths of the chords or lengths of segments that make up the chords. So this says if two chords intersect on a circle, the product, multiplication now, of the lengths of the chord segments are equal. So if you look here, we have a blue chord and a red chord. The blue chord is broken up into a segment called A and a segment called B. The red chord is broken into a segment called D and a segment called C. They're saying that the products of those segments are actually going to be equal to each other. So let's look down here and see how this works. It says find the value of x in the length of the blue chord. Well, if I look at the two sections of the blue chord, that would be this piece and this piece. Remember, we're going to do the product. So if I do x times x plus 10, I should be able to set them equal to the product of the two pieces of the red chord, x plus 7 and x plus 2. So x plus 7 all times x plus 2. So this is kind of an algebra practice here. X times x, so if we go ahead and simplify this, you guys are going to see some nice things cancel out. X times x would be x squared plus 10x equals x squared, remember FOIL here, plus 2x plus 7x plus 14. So plus 2x plus 7x plus 14. Now x squared on both sides, well, if we have x squared on both sides of the equation, they're going to cancel. So I'll be left with 10x equals 2x plus 7x, which is 9x plus 14. Subtract my 9x over, x equals 14. Once I have that, now the question said, find x and the length of the blue chord. Well, the length of the blue chord would be 14 plus 14 plus 10. So that whole blue chord is going to be 14 plus 14 plus 10. Well, 14 and 14 is 28, and then plus 10 would be 38. You go ahead and try. Go ahead and pause your video and see what you can come up with. Okay, hopefully you were able to break down your chords. So we have this whole chord here, which is this piece and this piece. So we're going to take the product of x minus 5 and 21. So we should have 21 times x minus 5. And then we have our other chord, which is this piece and this piece. So the product of 24 and x minus 9. Once we do our products here, it's just become, this is a little bit simpler than our last one. This is just distributive property. So we'll have on the left-hand side, 21x minus 105. And then on the right-hand side, we'll have 24x minus 216. I'm going to go ahead, if I subtract my 21x over, I'm going to get 3x over here. If I add my 216 to a negative 105, I should get 111. And then if I divide by 3, I'm going to get x equals 37. This one didn't ask for any specific chord measures or segment lengths, but just understand if it did ask you to do that, you could just substitute that value in. All right, that's it for today. So your homework is actually embedded within this lesson. You can pause here and kind of copy these problems down, or I posted a blank version of the notes on Portal and to Teams. So it says copy and complete the following practice problems. Please copy them in your notebook. I told you guys this is going to act as a review for a quiz. You want to be able to look right back in your notebook, see the picture and the work all next to each other. It says show work, box your final answer, upload then your notes and the homework problems to this assignment to receive full credit. So you can pause here and get these 4 questions, copy and complete. Then you can go on here and then pause this video and get these last 4 questions, copy and complete. Once you have them up, obviously turn them in and I will post the answers to those very soon so that you can check your work. Thank you and have a productive day.